Vanakkam. Hello everybody. Today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadikos 5th edition. And this is problem number 2.35 and we are going to solve this problem using mesh analysis. And we are asked to calculate V0 and I0 in the circuit. Okay, let's get started. Now we are going to solve this problem using mesh analysis. That means we are going to apply Kirchhoff's voltage law. So we start with this loop 1 in which we apply this KVL, so that we are going to write the voltage equation. So we start from this left bottom corner, we travel through this path. Here we have the minus sign is encountered first, so that we can write it as minus 200. Then we traverse through this path in which no element is found. Then we traverse through this path in which we are coming across two elements, 70 ohm and 20 ohm resistors, so that we can write it as plus 90, in which the current I1 is flowing. Then through the 70 ohm resistance, the I2 current is flowing. That's why we take it as minus 70. And through this 20 ohm resistance, I3 current is flowing. So we write it as minus 20 I3. And finally we go through this, it ends here. So rearranging them, we can write it as 90 I1 minus 70 I2 minus 20 I3, that is equal to 200. Dividing by 10, we can write it as 9 I1 minus 7 I2 minus 2 I3, that is equal to 20. So this is our first equation. So now we move on to loop 2. Here also we can apply KVL. So in this, actually we come across two resistors, 70 ohm and 30 ohm. So in total it is 100 ohm. So it can be written as 100 I2. Then the 70 ohm resistance is common to this first loop also, so that we can write it as minus 70 I1, that is equal to 0. In this also we can divide it by 10, so that we get this as 10 I2 minus 7 I1 is equal to 0. So rearranging this, I can write this as minus 7 I1 plus 10 I2, that is equal to 0. So this can be taken as equation number 2. Now we move on to loop 3. So here also we are going to apply KVL to get the voltage equation. Again we have two number of resistances, so that we can write it as 25. The current which is flowing through that particular path is I3. And then this 20 ohm resistance is common for loop 1 also. So it can be written as minus 20 I1. That is equal to 0. So dividing by 5, we can write it as 5 I3 minus 4 I1. That is equal to 0. So this can be taken as equation number 3. This can be rearranged as minus 4 I1 plus 5 I3. That is equal to 0. In this problem we have three number of loops, so that we have three number of equations formed, and we have three unknowns. So what are the unknowns? This I1, I2 and this I3. These three are the unknowns. And the second equation and the third equation have only two number of unknowns, so that we can make the remaining, that is the first equation, also consists of only two number of unknowns. So now you consider the second equation, that can be written as 7 I1 is equal to 10 I2. Then we can write this I2 as 7 by 10 I1. Now you consider this as the modified form of second equation, so that this second equation can be substituted in first equation, so that we can write this as 9 I1 minus 7 into this I2. I2 can be written as 7 by 10 I1 minus 2 I3, that is equal to 20. So that it is 9 I1 minus 4.9 I1 minus 2 I3, that is equal to 20. So this 9 I1 minus 4.9 I1 is 4.1 I1 minus 2 I3, that is equal to 20. So this is our modified form of this first equation, which consists of only two unknowns. Now you take this third equation. So we are bringing this third equation here. So it is minus 4 I1 plus 5 I3, that is equal to 0. So in order to solve these two equations now, so multiply this modified first equation by 5, so that you get it as 20.5 I1 minus 10 I3, that is equal to 100. Then multiply this third equation by 2, so that you get it as minus 8 I1 plus 10 I3, that is equal to 0. So you solve these two equations by adding them. These two get cancelled. So here you will get it as 12.5 I1, that is equal to 100. So I1 is equal to 100 divided by 12.5. So I1 is equal to 8 amperes. So we got one answer. Now we can find out this I2. Already we know that I2 is equal to 7 by 10 I1, isn't it? So in this we can write it as 7 by 10 multiplied by this 8. So that this is 5.6 amps. So what is I2 value? I2 is 5.6 amps. So we got another answer. So to find out the I3, we take or we consider the third equation. It is minus 4 I1 plus 5 I3, that is equal to 0. This is our third equation. In this we can substitute the value of I1, isn't it? So it is minus 4 into I1 value is 8 amps plus this 5 I3, that is equal to 0. That means minus 32 plus 5I3, that is equal to 0. 5I3 is equal to 32. So that I3 is equal to 32 by 5. So this is equal to 6.4 amps. So we got the third answer. I3 is equal to 6.4 amps. But in the question we are asked to find out this I0 as well as this V0, isn't it? So if you consider this I0, so it is flowing in this direction. This is I0. At the same time, I2 is flowing here in this direction and this I3 is flowing in this direction. So the I0 is equal to this I3 minus I2. So what is this? I0 value is equal to this I3 value minus this I2 value. So what is I3 value? I3 value is 6.4 minus I2 value is 5.6. So this is equal to 0.8 amperes. I0 is equal to 0.8 amperes. It can also be written as 800 milliamps. So we got an answer here. This is our required answer. Okay. Now we know that we need to find out this V0, isn't it? So what is V0? So V0 is the voltage which is developed across this 5 ohm resistance through which this I3 current is flowing. Ohm's law means V equal to IR. So here, what is the current which is flowing through this? I3. What is the resistance value? It is 5 ohm. So I3 value is 6.4 multiplied by this 5. So that we will get it as 32 volts. So this V0 is equal to 32 volts. So the second answer is also obtained. Thank you.